Long ago, before anything at all, what we now call the universe was very different. A lifeless void, from one side to the other. However, it was not empty. Indeed, it was incredibly densely packed, much denser than it is today. So why do I call it a void? You see, the matter which makes up our universe was spread so evenly, so uniformly throughout space. It's what thermodynamics would understand as a state of maximized entropy. Nothing could happen, or form, or change, as to do so would require a decrease in entropy, which we know is impossible. So, to explain why we have a universe at all, I should start by explaining what the matter in question was. The universe is made of a few fundamental particles: neutrons, relatively heavy particles with no charge; protons, particles with a similar mass but with a positive charge; electrons, with a very small mass and a negative charge; and pivots, particles with very small mass, variable charge, and uniquely, the ability to interact with the Verve. As mass is known to warp space through gravitational forces, and charges interact via electromagnetic forces, positive and negative attracting, the Verve exists as a third medium, bent by pivots, rippling as they move, and pulsing as they vary in charge. It was in this medium, the Verve, that the state of maximum entropy was broken. To this day, exactly why is a mystery, but all of a sudden, a great wave was sent through the Verve, and as this wave travelled, total chaos followed, first disrupting the pivots, which then collided with the other particles, knocking them into disarray. We call this event the Shattering. For billions of years, the wave bounced back and forth, pushing the edge of the universe out, and as it did, the power of this wave diminished, partially due to the energy used in churning up the universe, and partially through the wave itself simply becoming more and more spread out. Over time, the shattering became weak enough, and with large enough gaps between impact, that matter had time to coalesce, and gravity began to form the first stars, bringing light to the universe. Many of these stars were short-lived and unstable, as they were racked by periodic waves from the shattering. But it was in these early stars that fusion began to form the first elements. Eventually, these stars stabilized, no longer torn asunder by the shattering. They had become so dense in both mass and pivots that it would take enormous force for the Verve to impact them. Around these stars, planets formed, and after a few billion years, as things continued to cool, some of these planets became hospitable to life.